Hello, I'm Sabrina Oktaviani, and I'm going to explain about the rheology. So first, I'm going to divide it by first is pseudoplastic. So the behavior of pseudoplastic is decrease in viscosity as the shear rates increase. They become less viscous under stress, which means they flow more easily the more they are stirred or aggregated. For example, is ketchup, honey, and various polymer solution. For comparison to Newtonian fluid, unlike the Newtonian fluid, the pseudoplastic change their viscosity in response to change in shear rates. They become easier to stir the faster they are stirred. Next is the dilatant plastic. The behavior is increasing in viscosity as shear rate increase. They become more viscous under stress, which means they resist flow more strongly the more they are stirred or aggregated. For example, is cornstarch in water or some printer inks. And comparison to Newtonian fluids is the main Newtonian fluid maintain a steady flow behavior regardless of the force applied, while the dilatance becomes harder to steer under the rapid agitation. Next is Bingham plastic fluids. So the behavior is have a yield stress, which is the minimum stress required to initiate flow. Below this stress, they behave like a solid. Above it, they flow like a viscous solid. For example, is toothpaste, tomato paste, and some paints. And for comparison to Newtonian fluids, Bingham plastic differ significantly from Newtonian fluid in that they do not begin to float at all until a certain stress threshold is exceeded. And the next is melt flow index or MFI. Is a measurement used to assess the floatability or melt viscosity of polymer. It provides a indication how easily a polymer can be persist through the different process, and it is defined as the weight of the polymer in grams following in 10 minutes through a die specific diameter, a length by pressure applied by given a weight at a given temperature. The unit measurement of MFI is typically gram per 10 minutes, and the MFI test equipment is shown in this figure. When the volume extrude is measured, the melt volume rate is reported. In polymer processing, the MFI value correlated with polymer grade. This is done to choose appropriate processing methods. Next is the method um, of MFI, more detail. So first is the sample of a polymer is placed in a barrel of melt flow indexer, which is tend to be heated or in specific temperature. The temperature is determined by the type of polymer being tested, and then a piston with a known weight is used to apply the pressure to the polymer, and the amount of weight is also centralized based on the type of polymer. And next is as the polymer melt under the heat and pressure, it begin to flow through a small orifice at the bottom of the barrel known as a die. The diameter and length at the die are standardized to ensure consistency of measurement. The extrude polymer is cut regular interval, typically every 10 minutes, and the mass of extrude is measured. The mass of polymer at flow out in 10 minutes is recorded at the melt flow index. And the last is the weight is extruded polymer collected of the set period is the MFI value, typically reported in gram per minute. 10 minutes, this value provides quantitative measure of the material flow characteristic. Next is the effect of the molecular weight on polymer viscosity. The high shear rate will be a called shear thinning, is the tendency of some materials to decrease in viscosity when they're driven to flow at high shear rates, such as by higher pressure drops, shear thickening, or tendencies of some materials to increase viscosity when driven to flow at high shear rates. Low shear rates, polymer exhibit Newtonian behavior where the viscosity remains constant regardless of shear rates. In this regime, the viscosity is primarily dependent on molecular weight and is highly dependent following a power law relationships. As you can see in the slide, higher molecular weight will result in significant higher viscosity. And in the transition region, a noticeable reduction in viscosity occurs as the polymer transition from Newtonian to shear thinning behavior. The magnitude of the shear thinning increase with molecular weight. Next is addition of various additive effect and polymer viscosity. For the plasticizer, reduce intermolecular force, significantly lowering viscosity and enhancing flexibility, and it is crucial for application requiring soft, flexible materials. For fillers and reinforcement can increase viscosity and improve mechanical properties, but might complicate processing due to the increased stiffness and resistance to flow. For lubricants, aid in processing by reducing the internal friction, facilitating smoother flow during the molding or extrusion. For impact modifiers, increase the toughness without adversely affecting viscosity and essential for durable guts. And for compatibilizer, optimize the properties of polymer blends affecting viscosity by improving the interfacial adhesion between different polymers. And the last is real world example of the melt flow index or MFI values. For polyethylene, typically has an MFI range from 0.1 to 28 gram per 10 minutes and lower MFI value are used for product requiring high strength and stiffness, such as large blow molded containers, while higher MFI values are suitable for film application where our good flow and is necessary for thin product manufacturing. For polystyrene, general purpose of polystyrene might have MFI about 2 to 20 gram per 10 minutes. Lower MFI value are used for product requiring to rigidity and strength, such as applicants housing. Higher MFI are preferred for disposable like cups and container that needs to be economical in production and require easier flow molds. Okay, that's all from me. Thank you so much and have a good day. Thank you for listening. Bye.